Before doing activity 3, we need to talk about phase and phase shift. So phase is a property that indicates how much a periodic waveform is leading or lagging comparing with the original waveform. So for example, if my original waveform is a cosine function, which is the blue one here, then another waveform is called leading phase when it's coming before the original one. You see the red peak is coming before the blue peak. And it's called lagging when it's coming after the original one. So when it's leading, the phase is positive. When it's lagging, the phase is negative. So phase shift is when you have two signals, you choose one of them as the original one, and the phase of another one is called the phase shift corresponding to the original. So to calculate the phase and phase shift, we need to first know the time difference between these two signals and the period of those two signals. So the time difference is the identical point between these two signals. For example, these two peaks, the time difference is between these 2 points. And the period is the time interval between two identical points of two cycles in the same signal. So you see, this is the peak of the blue signal, and the next peak of the blue signal, the period is the time interval between these two peaks. So since phase is represented as an angle in degree or radians, so to calculate the phase, you take time difference divided by period and times 360 if you want it to be in degree, or 2 pi for radians. So the reason we use phase and phase shift in this lab is because it can be used to describe the voltage-current relationship. Remember, in capacitors, the current voltage relationship is following these equations. So if we apply a sinusoid signal, sinusoid voltage across our capacitors, because the derivative of a sinusoid signal is also a sinusoid, which means the current will have the same shape as the voltage, but might have a different phase shift. So for capacitors, we see here the peak of the current is coming before the peak of the voltage. So we see for capacitors, the current is leading the voltage. And if it's for the inductors, because the equation here, we actually swap the place of voltage and currents here, and the phase shift is also flipped it. So we see the peak of the current here is coming after the peak of the voltage. So we see for inductors, the voltage is leading the current. And in your lab instruction, it mentioned a mnemonic to remember this phase shift property, which is Eli the Iceman. So the middle letter, L and C, they indicate inductor and capacitors. So Eli means for inductors. E stands for voltage because it is used to be called electromotive force. E, voltage, is coming before the current, so which means voltage is leading the current. And I's for capacitors, the current is leading the voltage.